Good afternoon, everyone. I hope everyone can hear me. I'm audible. Yes. So today we are going to start our combined mathematics class, which is focusing 2025 A-levels. And so whoever gathered here decided to do mathematics for their advanced level subject stream. That's why we are here to discuss further on combined mathematics. Right. Before going to the proper lessons of the subject under the advanced level syllabus, I'll discuss with you, I'll explain you what is maths, why we are learning mathematics in advanced level, what is the coverage of advanced level mathematics in A-level subject stream, and how we have to work to face advanced level examination in mathematics stream, and especially the combined mathematics subject. What is the learning schedule we should prepare with? Right. We all know we started learning mathematics from our childhood. Even before going into kindergarten, we started counting 1, 2, 3 from our mother's guidance. Means mathematics is another source of language or another language we use to represent some ideas. That's why we are learning mathematics. Because maths is a language. It's not a subject. It's a language of scientific representation. Our scientific findings and our scientific ideas and our scientific outcomes from research and development mainly we represent with mathematics, because mathematics contains specific words and terms. Those are used as mathematical combinations and terms to represent our scientific ideas easily to people who know mathematics to that level of understanding. Good. Then, from our kindergarten to ordinary level, we started learning some more subjects like let's say English as secondary language, and then mother tongue, Sinhala. Then yes, mathematics. Then religion. Then art, science, and art. Then dancing. That sort of subjects. Then science. Then social studies or civics. Like 8, 10 subjects we learn from grade 1 to grade 11, or for past 10, 12 years, we learned all those subjects to find out what we are good with, and to get or to give idea to examiners or regulators or controllers what we are good with and in which area we can perform better. Even by learning those subjects, we ourselves understand and measure us, right? We are good at this particular stream. We are good in arts, or we are good with Sinhala language, or Sinhala language and literature. Maybe we are good with English, right? By knowing those competencies and our interests, as well as our parents' guidance and our future hopes, we decided to go to science stream, especially the physical science stream. That's why we are here to learn maths. So in physical science stream, so this wider range of subjects converge to or shrink to another set of subject streams, but like arts, then commerce, then physical science, that is what we call maths, then bioscience, then ICT, another new subject introduced by our education controllers or regulators for students to learn about new technologies and for them to have more other options compared with these classical options we had for long. Yes. And apart from that, 6-7 subject streams, we are having, or the subject stream options, we are having to proceed in our advanced level exams or advanced level classes. We ourselves decided to follow this. Maybe because of our parents' guidance, or maybe our personal interest, or maybe that we are planning to be a person who is mastering in this physical science stream. Maybe that was our dream. That's why we selected this. Apart from that, physical science stream is the stream which is having more option to select with if you even pass or fail your advanced level examination. Even if you get 3 S's compared to the other subject streams like arts, commerce, bioscience, or ICT, in mathematics or the physical science stream, you are having many more options to proceed with, even you're not able to perform well in your advanced level examination. That is the key feature of physical science streams. Even nowadays, people are advertising for, let's say, technicians, maybe some technical helpers, but they focus on advanced level math students or maths person who has gone through this physical science stream. Why? Because at least by sitting in advanced level physical science class, we acquired or we gain the knowledge about maths, physics, and chemistry. With maths, it trained our brain to solve problems analytically. So mathematics is an analytical language which trained our brain to do analytics better. That is another chance of learning mathematics. But not like that. We are not focusing to go for S pass or C pass or something. Here, if you follow the course properly and if you understand the theory, we easily get good marks in maths. Because once you understand the concept properly, you will be able to solve all the possible problems in maths. Even though the problem is in different nature, theory is same and with if you thorough the theory of maths, then it is easy to tackle all the problems given in mathematical domain or the mathematical papers or mathematical examinations. So best thing is to understand the theory proper from the fundamentals. Don't think that okay, I will understand the advanced concepts, fundamentals are no use. It's not like that. In maths, even we should have the proper understanding of addition. Even we should have the proper understanding of this. What is this symbol? And what is the meaning of this? And what are the uses of this? Without knowing this, we cannot go the next step. Even the fundamental like, division, the multiplication. Right? These things we should know thoroughly, even to perform well in our primary grades. Same way, in advanced level also, we are starting with fundamentals. We are teaching you the basics of mathematics. From that, we'll develop the advanced concepts, and each and every new concept will explain you the theory behind that, and will make you understand the theory properly. Then you will be able to tackle all problems easy. Even though when reading mathematical problems, for example, when you're following the exam papers, first class, you might think, it's very difficult and it's not able to understand. Oh, what is this? But if you subdivide the problem into small parts or the theory sections, then you can understand the problem in parts. That is the best way of understanding any complicated problem. Then one mathematical problem given in your examination paper might be using 3-4 theory sections or units we learned under this syllabus. And if you're not able to analyze the problem and subdivide that into different theory sections, then you will confuse yourself and not able to understand the problem proper way. So that again and again I am telling you, try to thorough the theory, not to by heart any problem. Don't by heart the way method of solving particular problem. No, it is not the way we should do maths. Right. And also, next, maths having very long history, and it's not a new subject, but it's a subject developing every day, because scientists, mathematicians, engineers, everyone discovering new mathematical theories, but that's not coming directly to our syllabuses, but they are publishing. Then once we confirm the theory, and once we apply the theory in advanced concepts and prove that theory is correct, thereafter it's coming to our learning syllabuses. Maybe the new concepts mostly coming to undergraduates or graduates or postgraduates, but with over time it might come into our syllabuses, like advanced level or primary education might be. Then we'll discuss about maths paper compared with the other 3 subjects we are learning in our advanced level. And before that, I'll give you a brief about how this A-level mathematics paper developed and what is the level it at today. Earlier, before 2002, 2000, sorry, before 2000, mathematics, the students who are following advanced level mathematics, they had to face four papers. Four papers. That is the physics, chemistry, and two maths papers. Come pure maths and applied maths. Pure maths and applied maths. There, pure maths, they purely discuss about mathematical concepts, theories. It's like they are conceptual subject. It's a conceptual subject mainly based on concepts, theories, and formulas, that sort of content. Means that section dedicated to theoretical side of mathematics, where you learn about algebra, you learn about the coordinate systems, you learn about differentiation, you learn about integration, you learn about complex systems, complex numbers, where the theoretical concepts you should know to represent your scientific knowledge is taught under pure mathematics. It was like that before 2000. And applied mathematics is such that it contains all the application of mathematics, the direct basic applications, and to give students an idea how to use whatever theories you learn in mathematics and how to represent or analyze or solve mathematical problems what we are finding day to day life. Such as, for example, let's say, motion, movements. We are studying motion compared to different scenarios, different conditions, and different states. So there we are using the concepts we learn in pure mathematics and apply with applied mathematics theories. Like if you consider force, in force we are having Newton's motion equations, since we are learning classical mechanics in this level, and we are applying that. And if we go to the sound or waves, yes, then we are using that concept to apply this. And then when we are going with the friction or that bodies not moving, but they are steady or stationary, but they are under different forces, then we need to analyze those systems, how they will behave with different forces. For example, the bridge or a structure or a building. So how those forces affects to my building are discussed under applied mathematics. That was the area students were learning before 2000. But later on, regulators, whoever deciding how our examination or our education system should be, not only Sri Lanka, but even foreign countries and some other educational institutions, they analyze students' capacity, capability, and future needs. Then they decided, yes, now instead of teaching them lot more theories and stressing them more in advanced level, let's relax them a bit, because they generation to generation, their learning abilities, their cognitive capacities and cognitive abilities are different. Because it's a genetic relationship, as we all know. So that time to time, we should revise everything, especially the education system, always should be revised with particular set of period. And in that way, thereafter, our Sri Lankan educators or academics or the education regulator decided, okay, we'll go with single subject, not two, but combining core concepts of these two subjects. Why core concepts? Since if anyone decided or selected to do higher studies in mathematical stream or engineering stream or any other stream, based on his stream of selection or stream of study or his advanced education, means the post undergraduate and graduate studies, he is having the option, ability or opportunity to learn further mathematics or further areas of the mathematics which is more relevant to his area of study. Instead of stressing students at advanced level, dumping all required and not required theories, education regulator decided, okay, let them learn core concepts and basics. And thereafter, in advanced studies, they learn their field of study and most relevant theories at those levels. So that is the basic decision of combining these two and making a subject called combined mathematics. Which is having examination. We are having two papers, combine 1 and combine 2, but the theories or the learning stuff is not that heavier than before 2002. Now it's little bit lighter. Most of the, for example, in pure mathematics, before 2000, even before 1997, students were learning about even the 3D geometry, the solid geometry, and plane geometry, and some other more the theoretical concepts. And if students learning pure mathematics before 1997, they were learning about lot more figures or functions or traces of Cartesian coordinate system like parabola, then hyperbola. Like, but here in combined mathematics stream, they limited to two set of theories, that is line and circle. Just I'm comparing. Even in pure mathematics also same. That time they were learning about inertia and moment of inertia, then trusses, then impacts in deep. But here in pure mathematics, we are not going that deep to like before 1977, so 1997, core concept like basically the motion and friction forces we are learning in combined mathematics after 2000. This is the way the subject evolved in Sri Lanka for advanced level, especially the mathematics subject. But we are having another subject called further mathematics, but most of the people are not taking that. That is for different selection, but mostly for students who are deciding to enter Sri Lanka universities. if they wanted to do engineering courses, they must follow physics, chemistry, and combined maths. But if anyone dropped chemistry and follow physics, maths, and ICT, then they are having the option to join. They are having the option to join computer science streams, not the other streams like mechanical or chemical or electrical or electronic or communication engineering. And even for the higher studies of the mathematics, that we can see that even instead of going for engineering studies, I'll continue my studies in further mathematics or physics or chemistry. I want to specialize on those particular fields. I can see students having the option to select that as well. But if you do ICT, then even Faculty of Science, your selection is limited. Basically, your selection is focused on computer science. So that is the way. Yeah. So I gave you an idea about the subject and its evolution. Then we'll discuss what is the weightage of combined mathematics in A level. The weightage in the sense, yes. Theoretically, weightage is same for all three subjects. Then now we shrink our study, or we limited our study to physical science stream since we are discussing combined maths now. Whenever students going into this physical science stream, they are having the option to learn, or not option actually, they should learn physics, chemistry, and combined maths. When normally in general for advanced level, we are having 30 to 31 months to complete our course of study. In the sense, that is my period of course of study after O-level examination and to next A-level examination, which is relevant to us, it's having 30 to 31 months of period. But because of this recent crisis, like the conditions like COVID, and we're not able to conduct the exams on proper time, our period of study might change a bit. So here we'll assume at least we'll get some 24 to 25 months to study my advanced level syllabus. And syllabus in the sense, study means study two papers and may get ready to see my advanced level examination. Then, if I want to get a balanced results and balanced study and study all subjects in same standard, we have to divide our study time properly. When we consider physics and chemistry, basically, mainly, let's say 8 months. First 8 months, we are mostly focusing on fundamentals and introduction to the subject or introductory subject areas in physics and chemistry. I'm not telling that first 8 months we are teaching you subject introduction, but the modules what we are discussing in these two subjects are not that difficult or that hard to understand compared to combined mathematics. So that what my advice to distribute your study time among these three subjects is like this. For example, let's say now maybe another 3, 4, maybe 5 months time, our schools will start and we have to attend our schools. Then weekdays we might get some 4, 5, no, not that much, maybe 3, 4 hours, 4 hours studies. The initial period, we are not putting that much stress on our studies. It's general person. That is the practice, and it's the common nature of human behavior. But there are special cases. There are special students, people. They might work hard, but what my advice is, you can work hard. You should not work hard. You should work smart. Why I am telling you that like that is, work hard means sometimes you may do 1,000 of problems from same subject or same module, but not understanding the problem as well as how you apply the theories, and you are not analytically doing the problem. You are not analyzing the problem and doing the problem in that manner, and just for sake of doing, you are doing. That is what I meant by work hard. But if you work hard, you might get some result. I'm not telling you are going to fail, but instead of putting much energy for hard work, put less energy and do smart work. Means select different problems of different nature and always try to understand and analyze the problem. While you are doing that, and if you thorough about in your theory, then it is easy to understand any new problem, because even though we do 1,000 problems before sitting to the exam, the 1,001 problem that what we are getting at the exam might be a very new problem to us. It's not, if we are lucky, yes, it might relate to one of the thousands we studied, but in some cases, in most of the cases, it might not. In that situation, what the experience what we are getting, or what's the training we are giving to our brain is doing problem in that to understand, read, and apply the theory what we use. We are training our brain to utilize theories and how to apply it proper way in practical situation. That is what we call doing an examination or doing a tutorial problem. But instead of doing the 1,000, if you do 100 problems proper way, proper analytical way, then tackling another new 1,000 problems are not that difficult. So that is why I want you to concentrate more on theory and try to understand the theoretical concept. Right. Then then these two subjects, yes, in first 8 months, we are not getting much hard theory, where we need more time to spend or understand it. But combined math from the start, from the beginning, the theory is what we are discussing, it is to that standard. In the sense, if we complete one module, it's completed as whole. Means you can, or you are in that level where you able to tackle, understand, or solve all the examination problems in that particular module. Because once we complete one module means we are preparing you to this examination level. That is the way combined maths syllabus also arranged. But in chemistry and physics, most of the theories what we are learning in the first modules are applied or you are used, or the concepts used to solve other theories what we are learning in other modules which are coming in far end of the syllabus. But combined maths are not like that. But it's like this. In combined maths, if you learn the initial part very thoroughly and try to understand it thoroughly, then it's easy you to tackle new problems. Why? Because now with the first stage of math study, you train your brain. You train your brain to start a good run. Now you warmed up your brain for a long race. That is what we are doing with first period of mathematics teaching. Once you warmed up your brain, then it will automatically go to that phase or that level. So what my advice is, spend 1/3 of your time, 1/3 of your time, I'm sorry, half of your time for first 8 months, in the first 8 months for combined maths. First 8 months, half of your time is allocated to combined maths and 1/4 for this and 1/4 for this. That is for first 8 months. Then once you complete this first 8 months, now you do in that form and that level, and first thereafter you equally divide your study time, and 1/3 for physics, 1/3 for chemistry, and 1/3 for maths. Maybe most of the time combined maths might finish little bit earlier than the other subjects if we are able to go in the proper planned way. Then either you are having extra time for mathematics, or even if you're not able to spend more time, or you are having difficulties in physics and chemistry, even last maybe 3-4 months, maybe you can allocate some more time here and with less time here. It depends on your way and your the way you study and the way you understood and the way the confidence you build at the last stages of the course of study. But this is here you are having experience to decide, okay, which time should I allocate to maths compared to other two subjects. But this is must. This is the best advice. Best way you should divide your timing, and this is must. Thereafter, yes, it should be equally divided. Why? Because not earning good results on one subject won't give you good Z score. To get good Z score, you should perform well in all three subjects. In earlier days, before Z score is introduced, or before Z score was introduced, if you earn 98 marks in physics and 95 in chemistry and 75 maths, for example, but you are in the higher grade, you are one of the good rankers, and you might able to enter to the first of your selection of the university. But nowadays, this is not like this. Your earnings, your performance in all the subjects should be balanced and it compared with other students who has done the same subject and it's compared with their performance in that particular subject. That is the way ECET score is formulated. So to earn a good ECET score, the best thing is you should perform well in all the subjects. That's why this advice for studies. Right. Now I hope you get an idea how to plan your next 2 years of time for your studies. But now these 2 years, your main focus is your advanced level, nothing else. You want to focus on other things, then your time is shared with them. Means your performance is degraded because of your time allocation for the why? Because now the performance is shared with some other thing as well. So these 2 years focus on advanced level mainly, but I'm not asking you to do only advanced level. You can do some extra thing, extra activities, but which is not that much harming to your studies. Right. Now we come to the subject that, as I said, earlier, combined mathematics are now trying to made smaller to one subject, that is combined mathematics. But not only that, the educators done, they have introduced new areas in your ordinary level examination courses as well. Even though we are introducing those required concepts in ordinary level examination, still educators are thinking there's a gap between O level and A level, because not all the students understood all concepts supposed to learn in ordinary level when coming to advanced level, because not like ordinary level, advanced level. In ordinary level, even last night study 2 can give you a good mark. Even you can earn A by studying last 3 months. If you plan your study properly for ordinary level and studying last 3 months can give you a good result. So whoever coming to do advanced level in math stream might lack of some of the basic or fundamental knowledge we are expecting you to perform well in your ordinary level. So that is what. So that because of that, even our main regulator for education, that is called NIE, National Institute of Education, decided a fundamental course to bridge the gap or connect the gap between O level and A level, especially the algebra. Well, because compared to other subjects you learn under ordinary level, algebra is more important when you are coming to advanced level, because we learn more algebra compared to the previous stages as well as ordinary level. So that NIE introduced a bridging course for A-level students who are coming under physical science, mathematics, or combined math stream, and for in school syllabus, it is allocated 12 hours of study. So our education regulators telling us 12 hours of study for bridging course. Bridging course. 12 hours of study bridging course. But here we are not going to spend whole 12 hours to give the bridging course, but today we'll start the bridge, and then maybe today after next class we can directly go to the syllabus, and parallelly we'll go with A-level syllabus and bridging course, because the bridging course is important, and I don't want to skip that bridging, even though we are very well done in our advanced level. Some of the concepts which is bit tricky used in advanced level to be learned and started with. All right. Then, okay, now you can take a book. Maybe this book, you can keep this book separately, not for A-level combined maths. This is bridging. So this is a separate course. So separate small course, but not directly test your knowledge in your advanced level. But this is important to perform well and earn marks. Yeah. Before that, I'm sorry, one thing I forgot. Before that, I'll just brief about the advanced level paper, and I'll introduce you the importance of this bridging course. The advanced level paper, it contains two parts, part 1 and 2, and two papers, PO1, PO2, oh sorry, combine 1, combine 2. Combine 1 contains the pure content of the syllabus, combine 2 contains the applied content of the syllabus. But to give the students non-zero marks, the regulators decided to give you with easy 10 problems. It's like a structured form of questions which you can easily write, and it's a simpler, not that critical analysis required there. And first 10, 1 to 10 are structured type. Structured type, where you can easily earn marks as well as you can easily answer it, and you will not end up with 0 in your maths paper. But where most of us seen 0 marks before 2000 papers, because since there the options were different. Then next, from 11 to 16, 17, you will get 7 problems of questions. 7 questions. There you are having the option to select 5 out of that 7. You have to answer 5 questions from that set, but they are in a safe form of problems. It requires detailed answers and detailed analysis, and it requires more time as well. The applied paper 2, the pure combined maths 2, paper 2 contains the same structure. Earlier, before 2000, the paper was like you are getting 12 problems. You are getting 12 problems, and you are having the option to select 6 and answer 6. Both the papers are like, but there you got 4 papers: PO1, PO2, applied 1, applied 2. So PO1 one selection, PO2 one selection, applied 1 selection, applied 2 one selection. But the stress was more compared to now. But you are having the flexibility of select options, and since the problems were that difficult, it's very that that tough, and it's very difficult to earn marks before 2000, but now it is not like that. Even you can pass the A levels and earn good marks, and if not got the opportunity to enter government universities, you are having the option to enter private universities. Even some of the private university degrees are well recognized, and recently government introduced one no interest student loan schemes. You can apply that loan scheme and go to the private studies if we not able to enter to government university because of the higher competition. Okay. That's the way the paper arranged, and now we'll do the bridging. Bridging. The bridging course. In bridging course, what we supposed to learn mostly the algebra, and right. Then I'll start with this. First thing is the binomial expansion. We require you to understand properly when we are entering to an advanced level. So we'll study binomial expansion. Expansion. But binomial expansion in detail we are discussing under algebra of the advanced level. But here we are filling the gap, and we will recall what is this? What is the expansion of A plus B? Okay. We know A plus B is A plus B into A plus B. I can write, but I'm giving you the detailed steps at this stage, but later on, I wanted everyone to do this binomial expansion in one stage. That means once you see this binomial expansion, the next line you should write the answer. I'm not expecting you to go through all detailed steps as an advanced level student. So, but then the theory A into A plus B plus B into A plus B. Why? Because here the expansion means we are multiplying A plus B with A, and we are multiplying again A plus B with B. You can copy while I'm writing. So we can do the exercise together. Right. Then next line I will expand these brackets. So what I am getting is A squared plus A into B, AB, plus B into A, BA, plus B into B, B squared. So I can write like A squared plus, here BA and AB are same nature. They are equal terms. Even though AB are interchanged, since it's a multiplication, they are same terms. So I can write this as 2AB plus B square. So my A plus B expansion is this. We already learned those things under my ordinary level exam syllabus, but I'm just recalling those things. Then next we see what is A minus B expansion. What is A minus B expansion? Same way, A minus B, A minus B squared expansion. Sorry. Then A minus B squared means A minus B into A minus B. Then A minus B, again A minus B multiplied with A and A minus B multiplied with minus B. Now the difference is instead of plus B, I'm having minus B here. So I have to take care how to handle the minus sign, and we have to do it properly. Right. Then I can write like this here, A into A minus B. Now minus B comes, so minus B into A minus B. Then I'll expand each braces separately. A into A square, A into minus B minus AB. Then minus B into A again, minus BA. Then minus into minus. We know minus multiplied with minus is positive, negative into negative. Positive. Oh, plus. So minus into minus is plus. B into B, B square. The same way, we can write A square. Then here minus AB minus BA, both are equal terms. Then, but they are with the negative sign and they added up with minus 2AB. They added up to minus 2AB and B square. Right. Then my A minus B expansion is in this nature. Right. Next. Yeah. Hope you copied this thing. So I'll erase it. And we'll go to the next combination required, and next combination we should recall. Now we'll see what is the expansion of this binomial, but into power 3 times. A plus B into 3 times. But we already found out what is the expansion for A plus B into 2. So we are using that. So that because of that, I'm writing this relationship in this form. Since I know what is this A plus B expansion, A plus B into 2 expansion. So A plus B into 2 expansion is A squared plus 2AB plus B squared. Right. Then again, the fundamental way I'm using here also A into A multiplied by 4 this term and B2 multiplied with 4 this term. So I'm writing A into A squared plus 2AB plus B squared plus then B multiplied with everything, B multiplied with 2AB plus B squared. Then I'll expand each braces separately. A into 3AQ plus A into 2AB means 2A into 2B plus A into B squared, AB squared plus AB squared, then sorry, BA into A squared, B into A squared plus here 2AB into B, then my B is multiplied with B again, then so it's 2B squared. So squared 2B squared plus B squared into B cube, B into 3. Then A3 terms, I'm not seeing any A3 terms here. But 2a squared b, here ba squared, even though they are interchanged, since it's a multiplication, those two terms are same, so I can add them together. So it end up with 3a square b plus, then I am having ab square term and 2ab square term. So those two terms two same, so I can add them together, 3ab square plus bq. This is my expansion of a plus b into 3 or a plus b cubed. Same way, I'm finding a minus b cube expansion. A minus b cube expansion. That same previously we can write a plus b into answer a minus b. A minus b into a minus b square. Why? Because a minus b square we already evaluated or we already calculated. So a minus b, then a minus b square is a squared minus 2ab plus b squared, which already found in previous exercise. Then again, I am multiplying a squared minus 2ab plus b squared with a. Then again, I am multiplying a squared minus 2ab plus b squared with minus b. So here minus b comes, we have to take care of that operation, otherwise this might go wrong. So I am writing a into this whole term a squared minus 2ab plus b squared. Then this time my minus b comes, minus b with a squared minus 2ab plus b squared. Then I am expanding this whole term. So a into a squared a cube, a into minus 2ab means minus 2a squared b, then a into plus b squared plus ab squared, right? Then minus b into a squared, it's minus b a squared, right? Now one tricky thing comes, that is minus b into minus 2ab, but we know minus into minus is plus, so the end result is plus 2ab squared. With the minus into plus, the result is minus b cube. So my final result is a cube, then see, this 2a squared b and ba squared, both are two same terms, with both are with negative signs, coefficient is negative. Here it is negative 1 and here is negative 2. So I can add them together and I end up with negative 3a squared b. Then ab squared, this is positive, and here positive 2ab squared I am having, but both are same form or they are equal terms. So I am adding together and I will end up with 3ab squared minus b cubed. Right. This is my expansion of a minus b into 3. Right. Right. Now we will see another important relationship. I'll erase this. That is, but this I cannot say binomial because it's having three terms anyway. We'll see this expansion. Expansion with three terms into square into 2. Yeah, that too important when we are dealing with advanced level algebraic simplifications. Right. A plus B plus C into again A plus B plus C. This is the meaning of this expression. So I done the first expansion. Then what I'll do is I'll multiply this with this with this, and C with. So I'll write those steps. A plus B plus C multiplied with C plus A plus B plus C multiplied with B plus A plus B plus C multiplied with C. Then I'll expand each basis separately. A into A square, A into B, AB. I'm not discussing about the sign because all are positive. So no sign complications appearing or indicating here. Then A into C, AC. Plus again A and B, BA. Here BA plus B square plus BC. Here C into ACA plus C plus C square. Then I'll write all square terms first. AB, A square plus B square plus C square. So first I taken these three terms to write here. Then I'll find out about the other remaining terms. Yes, here AB is here. AB term is here. And another BA term, AB, BA, both are same. And their signs also same. So they added two together and they added up to 2. They added up to 2AB. So I remove these two terms now. Then one CB term here and another BC term here. Both are same and they are added up to 2BC. So I remove this and this. Now the remaining is AC, right? One AC term here and another CA term, even though they are interchanged, they are same. So I'm writing 2CA. See the pattern. A plus B plus C into 2. It ended up with A square, B square, C square. A square, B square, C square. Each single term squared. And then each single term added. So each single term multiplied and raised into 2. That is multiplied to twice of it. AB into 2. Then BC into 2. CA into 2. The pattern. So these understanding these patterns are very important when you are dealing with future problems. Right. Okay. Yeah, basically, with the start of understanding the algebraic or binomial relationships, so then I'll erase it and I'll make a summary and we'll discuss few examples. Yes. Yeah. Now we make a note about we make a summary of about whole finding because we are using summary or the direct relationship to solve problems, not the way we discuss it, the detailed steps. So a plus b, the expansion is a square plus 2ab plus b square, and a minus b square is a square minus 2ab plus b square. Here, I'll show you one other relationship or another pattern between this and this. Instead of this one, I can write a plus minus b whole thing into square. Because remembering this is enough, no need to remember this. So here in this first expression, I'm applying b, sorry, minus b instead of b. Then what I'm getting is same. A square, no change of a, but here positive 2a multiplied with negative b, the result is negative 2ab. And the negative b multiplied with negative b, that negative multiplied with negative is positive. So that's why I'm getting positive b square. So no need to remember this, but remember this and apply the terms with their correct sign to get the result of the expansion. Try to understand the pattern. Then a plus b into 3, the expansion is a cube plus 3a squared b plus 3a b squared plus b cubed. And I'll write a minus b also and then explain you the relationship. Here also there are two relationships we need to understand. Right. Again, here it is a cube minus 3a square b plus 3a b square minus b cube. See here the relationship. There are two relationships we need to understand because that appears here as well. Later on, we will discuss about these coefficients, how to get the coefficients of binomial expansion. There's a theory called binomial expansion of n numbers. We'll discuss about that. Right here, one thing is all the terms they are index or power. order. Whatever the term we are using, the correct term is order, but I'm not introducing that order term now. Order of the term, it's a correct term. But the same power. Here, A's power is 3, no B terms. Here, A's power is 2 and B's power is 1. The addition is 3. Here, A's power is 1, B's power is 2, the addition is 3. Here, B's power is 3. So, all the terms, the addition or the total power is 3. The order of each term is 3. And if I assume that all the terms contain both A and B, here I can write B0, B into our 0. B to the 0 means 0. And here it's correct. And here A is missing, so I'll write A into 0. So here the expansion A's power is reducing. A into 3, A into 2, A into 1, A into 0. And B's power is increasing. B into 0, B into 1, B into 3, B into 2, B into 3. Later on, we'll discuss about how we are getting these coefficients, but you just remember the pattern. And not only that, here, again, the way we discuss about the relationship between B and real B, B and minus B, B and minus B. Here also, B and minus B relationship we can analyze. See, A's sign is positive, but okay, positive A into 3. But here, B sign is negative. If I put negative B here, my total sign is negative. And if I put negative B here, negative B into negative B, again the sign is positive, no change of sign. If I put negative B here, negative B into negative B into negative B, that is 3 times minus 1 into minus 1 into minus 1. The result is minus 1. So, if you remember this and apply the terms with the correct sign, you will end up with this. So, no need to remember this. Only remember this and apply always with the correct sign. Even A with negative sign, you can put, then it comes up like negative 1 A into 3, then here is a positive 3A square, and here negative 3A B square plus B square. If both the terms are negative, then here negative, here B is negative, A square, but it is negative. Here B square, A is negative, here negative, B cube negative. All the terms are negative. That way, you can solve anything. That's what I said. You try to understand, you need to understand the concept of the theory, not by heart anything. Right. Then what we learn is A plus B plus C into 2. The pattern is A square plus B square plus C square plus 2AB plus 2BC plus 2CA. He also said, even though we are not discussing about any negative in the examples, but here also the patterns is same. For example, let's say, okay, we'll do one thing and try to understand this. Let's say we got an expansion of this nature, A minus B plus C. So now we'll analytically get the result with this one. Okay, A sign is positive, so no change, A square. But now B comes with negative B, but negative B into negative B, the B square, again it is positive B square. C sign is positive, no change of sign, and it's C square. Right. Then here, A sign is positive, B sign is negative, positive into negative, it's negative. So the result is 2, so negative 2AB. Here again, B sign is negative, C sign is positive. So negative into positive, it's positive, negative. So the term is 2, negative 2BC. And here A sign is positive, B sign, C sign is positive, no change of sign. So it's 2AC. But in same way, if we get A minus B minus C, or minus A minus B minus C, or minus A positive C positive B, now we know how to deduce this or how to get this in one term. So I wanted you to understand or grab this concept. Right. By knowing these patterns, so I realize it, and we'll do some exercises to check whether we understood it properly. So these exercises I'll write first. I wanted you to write the answer in one step. In one step, not intermediate steps required. 2x plus 3y into 2. Then, yeah, second one is 2x y minus 5z into 2. Third one is 3x plus 2y into 2. Then fourth one is AB, this is AB minus 2 over C into 3 into 3, and fifth one is A plus B minus C into 2. I wanted, okay, I'll give you 10 minutes. No, 5 minutes. Write the answer in one line. Right. Yeah, I will write the answers directly in one step. Right. Here, concept is a square plus, sorry, a plus b square. The concept is a square plus 2ab plus b square. So a square, 2x square means 4x square plus 2ab. 2x into 3y is 6xy into 2, 12xy plus 3y into 3y, 9y square. Here, 5xy minus, sorry, 2xy minus 5x into 2. Right, here the sign comes 2xy into 2, that is 4x square y square. Now, multiplication of this into 2. So 2 into 5 minus negative. So negative 10 into 2, negative 20. Negative 20 xyz. Then minus 5z into 2, that is minus into minus again, plus 25 z square. Here 2x plus 3y into 2, 9x square plus 12xy plus 4y square. Here, yeah, it's cubic form AB minus 2 into C cube. So we know A plus B cube is A plus B cube is A cube plus 3A squared B plus 3B squared A plus B cube. Okay, we do that same way. AB cube, A3, B3. Then 3, A squared, AB squared, A squared, B squared into B. B term is 2 into, sorry, 2 over C but negative. So it multiplied with 2 C, then 2 over C. But I'll simplify it and I'll write the direct answer, that is 3 into 2, 6 over C, but sign is negative. Then next, again, 3 into AB square. A term is AB. B square. Now, 2 over C negative, negative 2 over square. It again, it is 4 over C square. C square, the sign is positive, and 4 into 3 is 12. The sign is plus. Then 2 over C into Q, but it's negative, so it's negative. 3 into cube is 8. Sorry, 2 into cube is 8. C cube. Take your answers. Here, again, but C is with negative. You already discussed one form. Two forms, I mean, all positives and one with negative. The same theory will apply. Okay. A square plus B square and negative C square, but negative C square comes to positive C square. Then multiplication 2AB, A positive, B positive, then no change in sign, positive 2AB. Then 2BC, but here C is negative, so BC with negative sign, 2BC. Then 2CA, but CA, again C is negative, so it's negative 2CA. This is the result for this exercise. And check your answers and correct it if it was wrong. I'll erase this. And I'll give you two homeworks. One is, given that this homework, I'll publish another tutorial once we complete this 3-4 basic concepts. Then all together I'll give you combine exercises as a tutorial. Then you can try that, and few selected things or difficult things I will discuss in the class next. This exercise, given that A plus B equals 4 and A plus B equals 4 and AB equals 5, find the values of A squared plus B squared and 2A cube plus B cube. Find the values of, that is numerical value. Numerical values of X. And second exercise, one, find the expansion of these things. 2A plus 3B into 2. The second one is 3A minus 4B into Q. And third one is X plus 1 over X into 2. Let's say into 3. 2. Then 4. A over 2 minus 2 over A into 2. 5. 1 over A minus 2 over A into Q into 3 and 6. A minus B plus 2C into 2. Copy this. And you can try at home. Okay. Hope we copied them. Then we'll go to the next section. That is, we'll recall our factorization knowledge. The factorization of algebraic equations. factorization. Yeah, I know these things are much familiar to you, but we'll recall them. Just first time write them, then you can try yourself. Then we'll discuss them. X squared minus 5x minus 6. Then next 2x squared minus 5x, sorry, 2x cubed minus 5x squared minus 3x. And third one is 3x squared, 3x squared minus 4xy minus 4y squared. I'll give you 5 minutes, then you can try them. Then we'll discuss the answers and I'll show you my method as well. I'll give you 4 minutes. Right? So in general, what we are doing with factorizing is we'll think about the midterm and try to get it using the constant terms factors. That is the way the second order expression we are factorizing. This is known as second order or the power 2. That is why this is called second order expression. So this second order expression, when we are factoring, we are trying to express second term. We are trying to get second term with constant terms factors. So the 6 can be written as 6 into 1. Then 5 is a combination of 5, 6 and 1. So negative 5 I can get by deducting 1 from 6. So what I'll write is x squared minus 6x plus 1x minus 6. So then from these two terms, I'll take x out, then I'll get x minus 1 plus here I'll take plus 1 out, then I'll get 6, x minus 6. Then x minus 6 is one factor and rest remaining is x plus 1. So here the factors for this expression is x minus 1, x plus 1. Here, since here the coefficient of x2 term is 1, we consider the factors of constant term, that is 6. But here in the second expression, my constant term, first of all, we have to do one manipulation. That is, you can observe that one term of x is common to everything. So that we'll take one x out and make this a second order expression. So I'll take x out. Then second term I'm getting, this term I'm getting 2x squared minus 5x minus 3, right? Then I'll keep x aside and try to analyze the expression inside the bracket. And there I'm seeing it's also another second order term or the x2 term expression. But this time I have to express the midterm with the product or the multiplication of constant of x, coefficient of x square term as well as the constant. This time 3 into 2 minus 3 into 2 minus 6. So I have to express minus 6. I have to find the factors of minus 6, which gives me 5 as its addition or subtraction. So what I can do is 2x squared, but 5 can be written as 6 and 1. So minus 6x plus x minus 3. Then x is 2x is common. So I'll take 2x out. Since I'm using brackets inside this, so I'll use square bracket. But anyway, if it is not confusing, you can use simple bracket, braces continuously. That's not wrong. But here I use square bracket for better visualization. The thing 2x out, then I'm getting x here minus 3 plus, then I take positive 1 out here, the 1 x minus 3, then I close this square bracket, and what I get is inside the square bracket x minus 3 is common to both the terms, so I'll take x minus 3 out, then here I'm getting 2x plus 1. So x minus 3, 2x plus 1 are the factors for this expression. But most of the time, one mistake with what we are doing is when we take x out, then next line we forget to write x, and thereafter x is missing and we'll end up with two terms. But you should aware that, or you should teach, or you should train yourself to check whether my answer is with the same order of the given problem, because here the order is 3 or x into power 3. So I have to check, you need to check whether you are getting the same x power, x index or order from the answer, because x into 2x here you are getting 2x cubed. That is another cross verification. Here also x into x, here you are getting x squared. Otherwise, you'll end up with wrong answer and you lose marks. But here also, Yeah, in some cases, it's difficult you to find the factors in one stage, but at least I'm not expecting you to write everything because this stage is not required. This stage is not required in general. Maybe this stage, sorry, yeah, this stage not required, but you can directly write this stage. Here also you can write directly this stage by seeing this. You should train yourself to get the things in this form. That is what we are expecting, and that is what we are teaching this bridging course to get you to this level. Get you to this level. Right. Then we'll come to the last one or the third one. Yeah. Here. Yeah. That now the second. Okay. Anyway, here you are getting x term, y term, and bit confusing. But don't get yourself confused. Simply think that y is another constant. Y is another constant. Y is another constant. So that this is one term and this is an expression of the second order expression of x. That way you can assume that it is easy to manipulate or tackle this problem. Right. Then let's see that how we need to express the center term or the mid term with factors of coefficient of x squared term and constant term. So x squared term constant is 3, coefficient is 3 or 4. Here the coefficient is 4. So what I can do is 4 into 3, 12. So I have to express 12 in terms of, so I have to express 12 to get this 4. So 12, I can express 12 as, I can express 12 as 6 into 2. 6 into 2. So 6 minus 2 gives me 4. So what I'll do is here 3x squared minus 6xy plus 2xy, because end of the day I need 4xy as the result of these two manipulation. That's why I'm writing like this. And not only that, my end result is minus 12. So minus 12 factors I have to write here. Minus 12 factors are minus 2 into 2. One set of factors are 6 and 2. Minus 6 and 2. Alright. Then 4 y squared. Then from these two, I can see, I can observe that 3x is common. So I'll take 3x out. Then here one x term is remaining, and here two y term is remaining. And from this, I can see 2y is common. So I'll take 2y out. Then here x is remaining, and here 2y is remaining. Then I know I can see that x minus 2y is common to both the terms. So I take x minus 2y out as a one factor. Then 3x minus, positive 2y is the other factor. But initially, by seeing the problem, yeah, sometimes you are feeling it's difficult, but we train ourselves To find out, get these answers in one step by seeing this. That is the requirement of this bridging. So that is the way you should save your time when you are working with your, especially the paper one, the combined maths paper one, part one, the first 10 problems. Otherwise, you cannot go to that standard if you are not maintaining the required speed. Required speed means saving time. So to save time, you should use short methods or most of your mind calculations. Most of your mind calculations, or use your mind to do the calculations for these sort of simple things what we already learned from ordinary level. All right. I'll release this. Yeah, I'll give you some nice examples and see whether we can handle those as well. We did three. Yeah, the fourth one. Yeah, fourth one. Yes. 2, 2 x plus 3 into 2 minus 7 x plus, yeah, 3 minus 4. The next one, two into two, 2a plus b into 2 minus 5, 2a plus b, then a minus 2b minus 3 a minus 2b squared. Yeah. Hope you can read. Yeah. 3a minus 2b squared. The last term is 3a minus 2b squared. All right. We write this 3 a minus 2b squared. 3 a minus 2b squared. Yeah. I'll give you 2 minutes. Check whether you can handle this. Right. This one, yeah. If I ask you how to manipulate this, you may tell me, yeah, we can expand this first, and then we can expand this, and we can simplify this expression and solve the simple second order term expression we are getting thereafter. Yes, I agree. No doubt, no argument. Yes, that is one of the correct and best methods you can apply. But here, what we are expecting from you is that if you ended up with this sort of problem, with this sort of expression, and or you realize that you can simplify, you can rearrange your terms to this form in mid of your exercise, right? Then instead of going to the longer calculations, what we are expecting is directly apply your factoring knowledge here. The simple thing is that now we are introducing the method called substitution. So we'll do substitution. We do the substitution. What we substitute, we'll say let A equals x plus 3. X plus 3 is our culprit, or x plus 3 is our term which gives bit problem. That's why we are eliminating that. Then we rewrite the expression with the x is 7a minus 2. Now it's very simple. It's a second order expression of very simple form, and yeah, 8 into 2, sorry, 2 into 4, 2 into minus 4, minus 8. That you see minus 8, we need to find out the minus 8 factors to find out a. Yes, minus 8 and minus plus 1 we can write. So 2a squared minus 8a plus a minus 4. Then from both terms I can take 2a out. Then a minus 4 plus a minus 2. A minus 4 is a common factor. A minus 4 to a minus 1. But this is not the final answer. So once because of our tension or stress or our we are hurried to finish the problem. By seeing this form, we are thinking, okay, we got the factors and we'll finish at this stage. Yeah, that is one of the common mistakes all of us doing. So, but you have to remember, this is not the original form of the equation. A term is a term what we introduce, and the original term is given with x. So we have to we have to substitute again the inverse of this. That is, again we have to resubstitute for a. Means a is what? X plus 3. X plus 3 minus 4. Then 2a is 2x plus 6 plus 1. The answer is x minus 1, 2x plus 7. But here also I'm not expecting you to follow all these steps. Yeah, this is required, and this is required, and this is required, and this is required. You can do with these 4 stages. This is not expected, this is not expected, and this is not expected. For explanation, I use those steps, but when you are doing your other exercises, don't follow these intermediate stages and train your brain to skip those things and do my calculations at these stages and get the final answer. Even if you realize that okay, without this substitution you can get same form of this nature, right? This nature, yeah, here we can do that. The substitution is for explanation, not an essential stage. And by seeing if you understood this is a second order term of x plus 3, and considering x plus 3 as your x, you can directly write the factors this way. Then this and this. These two stages, with these two stages, even you are able to finish your problem if you train yourself. Okay. Then I will come to the next one. This one, yeah. Here we are having two problematic terms, that is 2a plus b as well as a minus 2b. So same substitution theory will apply. So we'll say let 2a plus b equals to x and a minus 2b as y. Then I can simply write this as 2x squared minus 5xy plus 3y squared. Again, then the same way what we discussed about that problem number 3 previously. Consider y as constant. Then 3 into 2, that is 6. Then 6 factors to get 5, that is 6 into 1, you can write. So then you can write this as 2x squared minus 6xy plus xy minus 3y squared. Then these two terms, 2x is common, x minus 6y, sorry, 3y x minus 3y plus here y is common, so x minus 3y. Then we can see x minus 3y is common and remaining is 2x plus y. But again, this is not my final answer. We have to reapply the substitutions we have done. So x is 2a plus b, 2a plus b minus 3 y is a minus 2b, 3a plus 6b here, 3a plus and 2x is 4a plus 2b plus y, a minus 2b. Then we will simplify this. 2 with the minus ab, 6 in 7, 7b minus a, one term, and here 2b cancels out, and this is 5a. So I can write like 5a, 7b minus a. This is my final answer. Even if you simplify or expand those terms with binomial expansion theories and simplify and all the factors, you will end up with this. Right? Either way, because it's depends on your problem. Whether Does this problem easily can solve by substitution? Yes, we can. Because in future, especially with integration, differentiation, the substitution is commonly used. And not only that, even the algebra, right? We are using substitution. In complex numbers, yeah, we are using substitution. Okay, I guess things clear, and it's clear to you. If you're having any doubt or any problem, you can text me or you can message me. So now we are at the end of the session today. Because since it's an introductory session as well as that still we are training you for combined maths learning. We are not getting long hour classes. Initial classes might be 2 to 2.5 hours, maximum 3 hours if the exercises are a lot. Thereafter, we can, once we get our brain warmed up, then we can continue for long hours. If you don't have any doubt, then we'll conclude the class and we'll meet next day. If you have any doubt, you can let me know. I'll give you 2 minutes. If not, then I'll wind up the class. Okay then. Thank you very much. We'll meet next time.